This is a power supply for a GameGear. The GameGear originally used to take 6 AA batteries, had a LCD screen and a backlight, and you didn't get many hours for your money. So they brought out this, which is a rechargeable backpack. It's plugs into the GameGear. It uses the GameGear power supply, and inside it's got a rechargeable battery. It's got a little clip there that goes over. I guess you can carry it on your belt for true portable gaming. But over the years, like any rechargeable battery, it's no good anymore. It just doesn't work, doesn't hold charge. So going to have a go at replacing the battery inside this thing. She's got a couple of security screws on there. I do have somewhere the right bit for this, but I'm just too lazy to go and get it. So I'm using a pair of pliers to take out the 3 security screws. Once the screws are out, use something that's not going to mark the case to try and split the parts across. There's a couple of clips in there. If you just dig in there with something thin and plastic, you can push the clip in and it splits apart. Inside you've got the battery. You've got a little power connector that connects it to the PCB. And looking at the PCB, there's quite a bit of damage there on some of the tracks. It looks like they started to corrode a bit, probably due to the age of the battery. The battery's got a couple of bits of foam on it, stop it moving about. It's a 7.2 volt battery, and in this case it's a 1200 milliamp hour battery. So that needs to come out, and a suitable replacement found that's to say similar, obviously, voltage and a similar size as well. This is the one that I went for an 1800 milliamp hour, 7.2 volt car battery. It's got a slightly different connector on it, but that's okay. We can cut that and reuse that existing connector. So the PCB is held in with 2 small Phillips screws. So let's take those out and see what the other side of the PCB looks like. With the screws removed, it just lifts out. The wires that lead to the power for the GameGear look a bit flimsy, as does the soldering for the wire for the charge cable for the battery as well, so be careful with those. It's got a couple of through-hole capacitors on there, might as well replace those while I'm in here. But other than that, on top of the board, it looks a hell of a lot better than what the bottom of the board did with those traces that were a bit corroded. So we'll get these replaced. I'll also test the fuse while I'm here as well. It's an easy test, so why not? Just get a multimeter and test for continuity between the 2 ends of the fuses. That tests out okay. I may as well clean some of these tracks. Nothing's ever a quick job, is it? While I'm in here, let's get some of this solder mass removed. Just scrape it back to the bare copper, have a look, make sure the corrosion hasn't gone all the way through to the copper, and if it looks good, we can just put some more solder mask over the top to protect it, and then it should be good then, as long as obviously the battery isn't left to get into the same state as what the last one did. Just using a fiberglass pen, just working away slowly. Don't want to press too hard, don't want to destroy the copper underneath. Just keep working away until the solder mask is gone and the copper is exposed. And looking underneath once the copper is exposed and just giving it a bit of a clean there with some IPA. Some of the corrosion has got through, but it's not that bad. We'll do a little bit more cleanup later that's not on video, but it's not as bad at all. Testing resistance as well between all the points. The resistance is very, very low. So happy with that, happy that I can continue with this build. Again, while I'm in here as well, just using some deoxit on the switch, just give it a squirt, work the switch backwards and forwards, and just in case there's any corrosion got in there or any oxidations happened, then and again that switch should be good to go. So out with the desoldering gun, just taking off these 3 through-hole caps. So there's two 220 microfarad at 25 volt caps. This one was proving to be a little bit more stubborn, so give it a shot of a flux, and then just using the desoldering gun, just added some new solder onto the joint. And then the solder came away a lot easier, especially on boards that have had a bit of corrosion or just really old solder. Then don't be afraid to add new solder when you're removing solder. I know it's counterintuitive, but it really does help. The new solder makes the old solder flow a lot better, and it does come out a lot easier. And also it leaves you a lot neater job as well. If you keep struggling with the old solder and keep turning your iron up higher and higher, you end up damaging the PCB. So just add a bit more solder and it'll make life a lot easier. New caps in, just soldering these in place. Just sticking with the 2 similar capacitors at the moment, just so I don't get confused and lose where I am. On to the last cap. This one was a 47 microfarad cap. Again, just using desoldering gun. Just desolder that last cap, and that one popped out nice and easy. Bit of flux. Make sure you clean the contacts before you add the flux. Bit of flux, and then just soldering this last cap in place. Just double checking there, because there was a double joint, but that was meant to be. I can see that the 2 connections are part of the same trace. Cut off the spiky bits. Give it another clean. Make sure that nothing's dropped on the board and created a short, and just to get rid of some of that flux that I've used. And now to start on the job that I thought I was going to be doing when I took this apart. That's just to replace the battery. So I'm taking off the old connector from the old battery, and I'm cutting off the connector from the new battery. I decided to do this just one cable at a time. I thought if I'm just working on one, if I'm just burying all the wires one at a time, then there's going to be less chance of a short happening. And I don't really fancy having there you go, I was thinking about it then and stopped. I don't really want to have a battery shorting out on me while I'm working on it. So yeah, just work on one wire at a time. Just taking the ends back on both the wires. I'm just going to solder them up and then cover it with a bit of heat shrink. So you can see the white heat shrink already in place. I've joined the wires as best as I can, just using my fingers, and then adding the solder to make it a nice secure joint there. Once it's cooled, give it a bit of a tug test, make sure it feels nice and secure, which it does, so I'm happy with that. And then just repeat the same for the black wire. So exactly the same, just strip the ends out on the old connector and on the new battery. Join them up, bit of heat shrink, and then solder them together. Just putting the heat shrink in place and then using a hot air gun to shrink that down and make it nice and secure and nice and safe. And that's it. That's the new battery with the old battery connector. So time for a test. I haven't put the solder trace back onto the PCB yet. I'm just going to give it a quick test. So PCB is inside the case just to protect it against anything on the bench. I'm just going to hook up the new battery to the PCB. Switch is in the off position. I've dragged the multimeter out and I'm going to do a test. Now this is where things didn't go as I expected. So the switch is off and I was getting a voltage reading. Now obviously I wasn't expecting the voltage reading with the switch to be off. It was a fairly low reading. What's that, 6 volts, minus 6 volts. So I was expecting minus 9 volts coming out of the connector. But I was getting minus 6 with the switch off. So I was a bit concerned, thinking why am I getting a voltage when it's off? But okay, let's see what happens when I turn the switch on. And with the switch on, I was getting nothing. That just didn't make sense. But on reading, so I've got two issues here. One is I've got a low voltage, and the other one is I've got a reading when the switch is off, and no reading when the switch is on. Now, doing a bit of reading about this, apparently that is by design. So the low voltage aside, we'll come on to that in a bit. You switch the switch on when you want to charge the battery, and you switch it off when you want to use the battery to power the GameGear. So on this picture here, what I'm doing is I have the switch on the on position, the LED is lit, and the LED is a charge LED, so it is showing that the battery is being charged, but it'll only do that with the switch on the on position. So okay, that was completely opposite from how I thought it was going to work. But then what about this low voltage? So I just couldn't get this thing to give out 9 volts at all. So I thought, okay, well, maybe it's a load issue. Maybe there's some protection in there or something. I'm not. So what about if I hook it up to a GameGear power supply and test the voltages with that thing hooked up and turned on? But again, I wasn't getting what I expected. And tracing it through the board all the way up to where the power was coming in from the battery, the voltage was low at that point. And again, stepping through it, stepping all the way back on the cable, what I found is that there was corrosion in the connection. Remember, I cut the old battery connector off and resoldered it to this battery. In that old battery connection, the ends, the pins, had corroded and they weren't forming a good connection. So I had to spray Doxit into that, scrape the corrosion away, and when I did that and left it charging for a bit, I got the voltages that I was expecting. So yeah, it just goes to show it's not just the damage that you can see, the corrosion that you can see, it's also the stuff that you can't see that's going to cause you problems. So still testing with the GameGear power supply before I actually put it near a full GameGear. I just want to make sure I am getting the right voltages. So double checking, the switch is off as it should be. Pin 4 and 5 I think are ground, pin 1 and pin 2 are 5 volts. I'm getting 4.9 volts on pin 1. The last pin should give me about 32, 34 volts, yeah. And then about between 7 and 9 I think on that pin, and then about 1.2 on this pin. So all the voltages look good. So happy, time to test it with an actual GameGear now. Let's put a game in, hook it up to the battery pack, and turn it on. There we go, it's booting. So that is now just powered off with that rechargeable battery. Brilliant. That's exactly what I wanted. And it was just in there, just those pins, that one of them specifically was corroded. You can see on the other one a little bit better, you can see how it's a bit green around the edge. But it was a corrosion in there that was causing me the problems. We'll see how it goes. I may leave it or I may replace those connectors altogether. So the next step was to cover up the copper trace that I exposed earlier. So this is some UV activated PCB mask. So the idea is you just squirt it on, but it's not coming out because I haven't took the top off. So I'll figure this out in a minute. It's good to laugh at yourself. Alright, so that orange cap needs to come off. Yeah, well done. Yeah. Okay, right. And just blob this stuff on where the copper trace is. And then use something just to spread it out and cover up that copper trace. So I'm just going to use the end of a cotton wool bud and just move it around so it's got a fairly even coverage. Use a paintbrush, use whatever you want, doesn't really matter. It's just to protect that copper a bit. And then just a bit more of a smooth with the other end. Try and get it a bit more even. And try not to get it on any of the actual solder joints. And then as it's UV activated, just need to let it bake. Depends on the strength of your LED light. You can use a bulb, you can use an LED, you can leave it outside if it's sunny enough, doesn't really matter. Just wait for it to go hard. So that's it, it's baked on nicely there. Not the neatest job in the world, but it adds the protection. It's not in sight, so it'll do for me. Screw the PCB back in place with those two screws. Don't need to over tighten them, don't want to put too much stress on the PCB. And that's the button that I forgot to put in place, and unfortunately as that goes on the other side of the PCB, I needed to take it out and put the button back on, so don't forget to do that. Just looking, trying to work out where it sits and how the cable is going to run from the PCB to the battery. I'm going to reuse these old pads. They just hopefully will stop the battery moving about a little bit within the case. Again, damaged them a bit when I was taking them off. I could look for some alternatives, but there's enough sticky, there's enough padding there to do what I need it to do, so I'm just going to leave those old ones in place. connect the battery up to the PCB. There's enough space at the side of the case for it to go down. Just make sure when you run those cables at the top, you can see there, just pushing it in past that pillar, which is where a screw is going to go. You don't want to catch those cables with the screw when you close it all up. It should push fit quite nicely. Make sure the cable that goes to the GameGear, there's a little slot cut out for that, so make sure that's routed okay, and it should sit nicely together, and the power button should be in place as well. So it clips together loosely. These are those funny screws that go in place. This time I did try briefly with the pliers, and then I thought I won't be lazy this time, I'll go and get the proper tool for the job, and that made life a hell of a lot easier using the right screwdriver. So here's my first attempt, and just thinking, yeah, nah, that's never going to work. There you go, that's what you need. And with the right tool, it makes life so much easier. Fingers crossed, that should be it. So that's the size of the battery pack compared to the GameGear. It's a fairly decent sized battery pack. Just to show, nothing under my sleeve, sir. Battery connected to the GameGear, and it's in the off position, as we've learned. And there you go. This screen hasn't been replaced on the GameGear, so it's got its unique charm, but it's not great. So you find the right viewing angle to play your game, to get the brightness. I thought I saw a scratch on the screen then, that's what I'm messing about with here. But yeah, there you go. It's powered it up fine. I haven't done a run test yet to see how long I actually get out of this battery pack, but yeah, I would suspect it should easily last. I don't think I've got anything that shows me a current draw actually, but yeah, I'll do that test and maybe post in the comments just how long it's going to last. But obviously, if you replace the screen as well and go for a modern screen that doesn't have that battery sucking backlight, then you should get some good length out of it. The last job to do is just put on that essential belt buckle, and that's it. That's all done. So a little bit longer and more involved than I thought this was going to be when I thought I was just replacing a battery. Bit of corrosion to clean up, a few caps to replace, and learn a little bit along the way about just how the on-off button works, but we got there in the end. Thank you for watching.